Okay, so here's some revision on Pythagoras' theorem. So the following triangle, as you can see, we're looking for x. Okay, which is there. Okay, so we're looking for x. So remember our formula that we use, and our formula is when we say a squared is equal to b squared plus c squared. And remember that our a is the longest side. Now I think I actually gave you that, come to think of it. I kind of gave it as c squared is equal to a squared plus b squared. But it doesn't actually matter which way around, as long as you know that this one here is the longest side each time. Okay, so I'll rub out that first one there. So what we're going to do here now is we're going to mark our sides. So I've kept the c squared is equal to a squared plus b squared, and we always go our longest side, or the side facing the right angle. So there's my right angle there. Side facing it, we're going to call c. And now it doesn't matter what sides we call a and b. So if you want now, we're going to plot them in now instead. So instead of c squared, it becomes x squared. Instead of a squared, it becomes 5 squared. And instead of b squared, it becomes 10 squared. So now at the moment here, we've got x squared is equal to 25 plus 100. X squared is equal to 125. And now we have to sort of, I suppose, maneuver this about. So I'll put this over here. So if x squared is equal to 125, well then, how do we find what x is? We switch it around. X is equal to square root of 125. Okay, now you'll probably find if you put that into your calculator. So that's my answer there now. X is equal to 11.18. Now you probably can see here, x equal to square root of 125. This here is called surd form. Okay, so that's surd form right there. So surd form. Surd form just doesn't basically use decimals, it's just as a square root of a certain number. And that's Pythagoras' theorem, of course. The other type of Pythagoras' theorem is where you're manoeuvring them around differently, where instead you might have had, say, this side could have been 10, and we had to find this side here, which means this 10 would have been over here. And it would have been just about manoeuvring back and forth, numbers, different sides of the equal sign. Of course, remember with algebra, once you bring something over an equal sign, it just changes the sign. So you're balancing out opposite action. Okay, and that's it.